Hi everyone, welcome back to Chem Help ASAP. In this video, we are going to be talking about naming acids. And yes, we will cover both the binary acids and the oxyacids because they have different sets of naming rules. But let's see how this actually plays out. We are going to start with naming our binary acids first because I think they're easier. So when we name our binary acids, we first are going to start with the hydro prefix. Our second rule says that we are going to name the anion with the ic or ic ending. And our third rule states that we will simply add the word acid to the end of the name. So let's first go from the molecular formula to the name. We can see my first compound here is HCl. Again, it is a binary acid because it is simply hydrogen and chlorine. There are only two elements here. So I will start with my hydro prefix. Now I'm going to name the anion with the ic ending. My anion is chlorine. That will become chloric. And then of course my last rule just tells me to add the word acid to the end. HCl, you guys are probably familiar with this acid, is simply hydrochloric acid. Let's take a look at our second example. H2S. Now, this is still a binary acid, even though it actually has 3 atoms, because it does only have 2 types of elements. It's simply hydrogen and sulfur. Therefore, it is a binary acid. So I will start with my hydro prefix. My sulfur, again, I'm going to name with the ic ending. Becomes sulfuric. And again, my last rule simply tells me to add the word acid to the end. H2S is simply hydrosulfuric acid. Okay, now let's go from the name to the molecular formula. So my first example here, hydrofluoric acid. Of course, the acid tips me off that this is an acid. I need to use my acid naming rules. The hydro tells me that this is a binary acid, so I've used my binary acid rules. So I know I have 2 elements, H and fluoric must have come from fluorine. Now, just like with any other ionic compound, I need to do my little bit of math to make sure that I have the right number of each element. Hydrogen, of course, has a charge of +1. I'm going to add that to my charge for fluorine, which has a charge of -1. All right, as written, that is a neutral compound. Hydrofluoric acid is simply HF. Great. Let's go to our next example. Hydroiodic acid. Again, the acid tells me I'm using my acid rules. The hydro tells me I'm using my binary acid rules. So I know I have H. Iodic simply came from iodine. Now do my quick math to see if I have a neutral compound. Hydrogen +1. If I find iodine on the periodic table, I see that it has a charge of -1. Again, that is a neutral compound as written. Therefore, hydroiodic acid is simply HI. Okay, now let's tackle our oxyacids. So if I switch pages and let me switch back to my blue. Oxyacids obviously are acids that contain oxygen in them, and they do have a different set of names. So let's take a look at our rules here for our oxyacids. We need to look at the name of the polyatomic anion in our oxyacid. If the polyatomic ion ends with the ATE ending, we need to name our acid with the ic or ic ending. If our polyatomic anion ends in ITE, we need to change that to the OUS ending. So it's very key to know your polyatomic ions here so that you can make sure you name your acid correctly. And just like with the binary acids, we will add the word acid to the end of the name. Okay, let's take a look at our first example. H2SO4. I know this is an oxyacid because it has oxygen in it. Also, I have a polyatomic ion here. So if I look at my polyatomic ion in my acid, I see that it is SO4. So again, I'm going to use my quick reference here on the left side, and I'm going to find SO4 down here at the bottom. I see that is sulfate. That is an ATE ending. Therefore, I'm going to use my first rule here, and that acid name is going to go to an IC ending. So my sulfate becomes sulfuric. And again, I simply add the word acid to the end. H2SO4, again, you may already know this one. This is sulfuric acid. Let's go on to my next example. HNO2. I'm going to find that polyatomic anion NO2 right here. Its name is nitrite. So that is an ITE ending. That means I'm going to go to the OUS ending. So it's not going to be nitrite, but nitrous. And again, I'm going to add the word acid to the end. HNO2, nitrous acid. Related but not the same to nitrous acid is HNO3. NO3, of course, comes from nitrate, so my name is going to change. Instead of nitrous acid, it's going to be nitric acid. And you can see what a difference adding simply one oxygen atom does to the acid name. Let's reverse and go from the name to the molecular formula. So here I have phosphoric acid. Again, the acid is the tip-off that I am using my acid rules. Notice there is no hydro prefix, therefore I know I must be using my oxyacid rules. So when I see phosphoric acid, I see that ic ending and know that it must have come from the polyatomic ion that ends in ATE. Therefore, if I look to the left, here I see phosphate. So that is PO4. It has a charge of 3 minus. Now, of course, with an acid, my cation is known to be hydrogen. So I have hydrogens in front. And now, just like with any ionic compound, I need to know how many of each I have. So let's switch to green and do a little bit of math. Hydrogen, of course, has a charge of +1. I'm going to be adding that to my charge on my phosphate, which has a charge of -3. And of course, right now, I have an overall charge of -2, which I do not want. Therefore, I need to have a multiplier here of 3, and that changes to 0. I must have 3 hydrogens here. Again, let me rewrite this a little bit neater without all my charges. Phosphoric acid, H3PO4. Let's do another one. Chlorous acid. Again, the acid is a tip-off that I'm using my acid rules. There's no hydro prefix. I must be using my oxyacid rules. So I take a look at this OUS ending, and I know that it came from the polyatomic ion that ended in ITE. So if I take a look at my polyatomic ions over here to the left, I want to find the polyatomic ion that ends in ITE. Here it is. Here is my chlorite. That is ClO2. It has a charge of 1 minus. Again, because it's an acid, I know that my cation is going to be hydrogen. Now I will do my quick math just to determine how many hydrogens I have. Hydrogen, of course, +1. I'm going to add it to my chlorite, which has a charge of -1. And this one's very easy. It is neutral as written. This is going to be 1. Of course, I do not actually write that when I write my final compound. Let's write this a little bit neater. HClO2. Last example, carbonic acid. Again, I'm focusing in here on this ic ending. So if I go to my polyatomic ions, here I find carbon 8, ATE. That is CO3, it has a charge of 2-. I know I have a hydrogen, I just don't know how many quite yet. Let's do our math. Hydrogen has a charge of +1. I am adding that to carbonate. Let's see, right now got an overall charge of -1. That is no good. But if I put 2 here, then that becomes a neutral compound. Therefore, I have 2 hydrogens, and let me just write this out a little bit neater. H2CO3, that is carbonic acid. It can be easy to get your acid rules mixed up between binary and oxyacids. The main thing that I look for is that hydro prefix. If I see the hydro prefix, I know it must be a binary acid. If there is no hydro prefix, then I am immediately going to go to my oxyacid rules. I hope this helped you, and thanks so much for watching.